Hi, my name is Agam Singh and this is Lab 3 Magnetic Field of a Permanent Dipole. The goal of this lab was to measure the distance dependent on the magnetic field due to a small bar magnet and then compare the measurements to the distance dependent predicted by the equation for the on and off axis magnetic field derived by the Biot-Savart law. And just to clarify, a magnetic field can be produced by a current flow, movement of charge, or a magnetized material. Before we could even begin the lab, we had to set up a few things. First, I had to download the Firefox app for this experiment. Then I had to align my phone to the magnetic North Pole, which is also when the magnetic field of the X component is equal to 0. I had to find the magnetometer chip on my phone, and I had to collect the data outside so that nothing could affect the magnetic reading. For this lab, we had to know that the magnitude of the magnetic field due to a bar magnet falls off with distance. That is, the magnitude decreases as the observation location is moved farther away from the bar magnet. This distance dependence can be expressed by an equation form of B bar equals KR to the nth power. So for this experiment, we had to find the distance away from the magnetometer chip that produced the magnitude of a magnetic field of 20, 70, 120, 170, and 220 nanoteslas. After we measured those distances, we had to measure the off-axis or the perpendicular magnetic field shown on the picture to the right. After that, we used that to determine the and coefficient of the distance dependence and mu. On the slide, you can see all the data that was collected during this lab. We have the distances for each set of magnetic field. Below it produced the averages, and then after that you have the off-axis fields and those averages, and then it produced a graph. On this slide, you can see a closer look of the natural log of b of x versus the natural log of r graph. The line varies, but n is constant along with k, so it should be a straight line with the y-intercept being ln of k, which we can use to derive a bunch of other things for this lab. On the slide, you can see the calculations that were done to find mu and n. Using the equations that the magnetic field equals kr to the nth power and the natural log of the magnetic field of the x component equals the natural log of k plus n and the natural log of r, we can find these values. As said before, we had the equation that negative 3.71x plus 14.64 and the y-intercept being 14.64, we can find n by using k equals e to the negative 14.64, which equals 5.15 times 10 to the negative 7. So our observed n value is negative 3.867. We use the equation that is highlighted below of kr to the nth power equals mu over 4 pi times 2 mu divided by r to the third power. We can find that mu is 3.312 meters squared. This slide shows the code of the computational model used in this lab. We first create a gray cylinder to represent the magnet. After that, we create a function to create the magnetic field. After that, we create our B scale, we plug in our distance we found in for a lab, and then we create our arrows for the magnetic field and the distances that we observed. After that, we create also arrows for the magnetic field at the 45 degrees off axis. This shows the output of our code. The bar magnet is represented by the gray cylinder, the orange arrows represent the B field on axis, the cyan arrows represent the B field perpendicular to the bar magnet, and the green arrows represent the B field at 45-degree angles. And on the left, you can see the outputs that it shows. What if you had oriented your experiment to compensate for the magnetic north and had instead laid out your meter stick at some intermediate angle with respect to the Earth's magnetic field? How would your results have changed? To break it down, the bar magnet x component plus the Earth's x component, which no longer is here, would have produced much larger x value results. And what if you had to stick your two identical magnets together end to end, run the experiment again? How would you expect your measurements to differ? If I had to do that, then the measurements would have been greater since there would be a greater magnetic force. Double the x values and double the mu. Thank you for watching.